Well, hello, geometry. Welcome to lesson 5 for inequalities in one triangle, right? So this is a sort of algebraic take on triangles. It actually is very important because it talks about the existence of triangles and how angles and sides are related. This is actually a good precursor to trigonometry in, I think, topic 8 with right triangles, just because of the comparison between angles and sides. And that's basically what trigonometry is. Okay. All right, so let's take a look at some problems here, or some ideas. All right, so it says investigate side and angle relationships. Draw a right triangle and a non-right triangle. How is the largest angle measure of each triangle related to the side length, right? So we want to compare the largest angle to the longest side. So let me get to Savas. All right, so here we go. All right, so here is a right triangle. So notice here that angle A, the right angle, is the largest angle. What side is the longest side? Well, that would be the side across from angle A. That is 13. Okay, so be aware of that. Notice we call this angle A, and side BC is the longest side. So notice the comparison between the vertex and then the naming of the segment that's the longest. All right, now it says make a non-right triangle. So let's make an obtuse triangle. So let's draw that up here. So there we go. So now 119 is the biggest angle, so A is still the biggest angle. And notice that BC, the side across from, is still the longest side. And now let's make an acute angle. Let's try not to let's not let A be the biggest angle. There we go. And now we're letting C be the biggest angle, right? 85 degrees. And now it is side AB that is the longest side, the side opposite. So in summary, right, I think that the largest angle appears to be opposite, or across, if you will, from the longest side. So the largest angle appears to be opposite or across from the longest side. Oi. Maybe it's because I'm doing that on Savas. Sorry. It's lagging big time on my end. All right, cool beans. All right, so let's take a look back at our notes. Let's see what this investigation leads to. The first theorem. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. Opposite, across, right? There we go. So in this picture, so notice we labeled the side lengths lowercase letters, so A, B, and C, and then the big angles are the vertexes or vertices of the angles. So it's telling you that B is bigger than A. So if B is bigger than A, then the angle across from B is going to be bigger than the angle across from A. So then angle B must be bigger than angle A. And there we go. All right, so let's see if we can apply that to a picture. Here we go. To support a triangular piece of a float, a brace is placed at the largest angle and a guide wire is placed at the smallest angle. Which angle is the largest? Which angle is the smallest? Okay, so if we take a look at this picture, right, AB is longest side at 13 feet. So the angle opposite of that 13, angle C, so angle C is the largest angle. Now, smallest angle. So segment AC is the smallest, I say shortest, right? Shortest, sorry. Is the shortest side. At 10 feet. So that means the angle opposite of that, which would be angle B, is the smallest angle. And the powerful thing about this is that we have no idea what those angle measures are, but we do know how they compare to each other. right? So that means the brace must be placed here. So the brace is going to go at C. And that means that the guy wire, green, the guide wire gets placed at B. Cool. Alrighty then. Next. Ooh, I think it's a proof time. Here we go. So we're going to use indirect reasoning to prove this theorem. So again, remember I skipped this idea of indirect reasoning. I apologize, or we didn't watch the video. But we're going to use that here, and I'll show you how. So remember, so we're given that J is bigger than G. We're going to prove that GH is bigger than HJ. So remember, the number one step in an indirect proof is to assume that the proof is not true. We're going to assume that GH is not bigger than HJ. So after that assumption, so there's two ideas, right? What if GH equals HJ? If GH equals HJ, then these two would be congruent. This would be an isosceles triangle. Angle G would have to be congruent to angle J. Then the measure of angle J would equal the measure of angle, getting ahead of myself, the measure of angle G by the isosceles triangle theorem. However, we were given that angle J is bigger than angle G, so this contradicts the given. But this contradicts the given. Okay, the second idea is what if GH is actually less than HJ? Okay. Well, if GH is less than HJ, then we just talked about if GH is less than HJ, then the angle opposite GH is less than the angle opposite HJ. So then, by Theorem 5.9, the measure of angle J would have to then be less than the measure of angle G. But again, this contradicts the given. Thus, GH must be greater than HJ. And Theorem 5.10, which we'll talk about in a couple slides, that's actually the converse to Theorem 5.9, right? This one starts with the angle measures leading to the order of the side lengths. So it's just reverse order. So I find it interesting how they haven't explained that to you yet, but, discovery learning, right? That's what it's all about. So let's use the idea. So which side of triangle KLM is the longest? So we're going to use the angle measures to see which one is the longest. Now, they give us two angle measures, so I don't know what that third angle measure is, but I think I can find it. So that's step one. Find the measure of angle K. And we do that using the triangle angle sum theorem. So we know that X, which is the measure of angle K for me, X, plus 50 plus 62 should be 180. Combine 50 and 62. X plus 112, equals 180, and subtract 112. X is 68. Angle K is 68 degrees, meaning that angle K is the largest angle. Angle K is the largest angle. Well, then the side opposite of K will be the longest side. Thus, segment LM is the longest side. And there you go. So officially speaking, the converse of Theorem 5.9, which is Theorem 5.10, says that if two angles in a triangle are not congruent, then the longer side lies opposite the larger angle. So again, in this picture, B is bigger than A, so the side opposite of B, which is side B, is bigger than the side opposite of A, which is side A. And again, you could use the letters too, so segment AC is greater, or I'm sorry, the length of AC. So A to C is greater than the length of B to C. Okay, I'm going to stop there. The triangle inequality theorem is the topic of video number 2. Can't wait.